Bismillah ar-Rahman ar-Rahim. Today we are going to discuss hemochromatosis. Let us start by defining what's meant by hemochromatosis. Hemochromatosis means the position of excessive amounts of iron in parenchymal cells. Or in other words, when the iron level inside our blood gets high, iron will be deposited in different body tissues, like the liver, causing liver cirrhosis, into the skin, causing discoloration of the skin, what we call it bronze skin, into the pancreas, causing diabetes mellitus, and other tissues which we will discuss later on. If we look to the hemochromatosis, we'll find two types of hemochromatosis are present. Either it is primary or hereditary hemochromatosis, where there is mutation of certain genes that can cause excessive absorption of iron, causing hereditary hemochromatosis, or secondary or acquired hemochromatosis, which may be due to iron overload, as in cases of thalassemia major, sickle cell disease, chronic hemolytic anemia, etc. In such conditions, there is excessive hemolysis of blood with increased amount of iron released from the hemolyzed blood into the circulation, and such iron, when gets high, it will be deposited in different parenchymal cells. Again, there may be secondary to chronic liver diseases, as in hepatitis C or alcoholic cirrhosis. And if we go back to the primary or the hereditary hemochromatosis, we'll find that it is due to mutation of certain genes, and these genes produce proteins which regulate the level of hepcidin. What are these proteins? It could be an HFE related proteins, and the gene of HFE protein is located on chromosome 6. When such gene is mutated, the protein will have point mutation at the position of 282, where cysteine is replaced by tyrosine. And this, when it is homozygous, it is the most common type of hereditary hemochromatosis. It is termed type 1. So in type 1, there is a mutation of the HFE gene in the form of replacement of cysteine with tyrosine at position of 282. Other types of hereditary hemochromatosis which are not related to the HFE protein are the type 2A, type 2B, and type 3. In type 2A, there is a mutation in the gemovolin gene. In type 2B, there is a mutation in the hepcidin gene itself, and in type 3, there may be mutation. There is mutation in transferrin receptor type 2. All the four types of mutations will result in decreased amount of hepcidin, as these proteins are inducers for hepcidin. The fourth type, or type 4 hereditary hemochromatosis, would result when there will be mutation in ferroportin gene. Such mutation will cause the ferroportin resistant to the binding of hepcidin, and as a result it will not be degraded with excessive absorption and release of iron. This figure will summarize the different causes of hereditary hemochromatosis. As we see here, it could be due to mutation of HFE gene, which is type 1, or hemojuvelin type 2A, hepcidin type 2B, or transferrin receptor type 2, as in type 3 hereditary hemochromatosis. All such conditions, 1, 2, 3, 4 conditions, would result in decreased senses of hepcidin. As a result, the ferroportin will be released from the inhibitory effect of hepcidin, with increased iron absorption from the intestine and release from macrophages and liver. That would increase the level of iron, and consequently the transferrin will be highly saturated, and it carries the iron to the different tissues where iron is precipitated in different parenchymal tissues, as I mentioned before, as in the liver, the pancreas, under the skin, the gonads, maybe the pituitary, etc. This would cause hereditary hemochromatosis. In type 4 hereditary hemochromatosis, the mutation is in the ferroportin gene itself, and such mutation will render the ferroportin protein resistant to the effect of hepcidin, with release of the inhibitory effect of hepcidin and increased absorption of iron and its deposition, causing hereditary hemochromatosis. This figure shows the effect of decreased hepcidin level, as in type 1, 2A, type 2B, and 3 on iron absorption and release. Let us notice here, when hepcidin is decreased or mutated, there will be increased absorption and release of iron to the plasma, where the iron will bound to transferrin, causing increased transferrin saturation percentage. And when transferrin is saturated, it will go to the different tissues where it deposits its iron to the different parenchymal cells, like the liver, the pancreas, other tissues. In type 4 hereditary hemochromatosis, the ferroportin is released from the inhibitory effect of hepcidin, so there will be increased absorption of iron from the intestine and release from the different storage form of iron, or from the macrophages, and increased of the plasma iron bound transferrin. The saturation of transferrin will become higher than 45% of transferrin is saturated, and that would cause the iron to be deposited in the different parenchymal cells. Now, what are the complications of hemochromatosis? As we mentioned, that when iron becomes high, the iron becomes increased absorption as a result of decreased hepcidin or mutation of ferroportin. Transferrin saturation will become high, and it will carry iron to different parenchymal tissues. Such iron will be deposited in such tissues, causing their destruction. As a result, hemochromatosis usually takes time for iron to build up in different parenchymal tissue cells to start to appear. It usually starts at the 40th for male and 50th for the females. Hereditary hemochromatosis is the most common hereditary disease in Caucasian or the Northern European populations. Precipitation or deposition of iron of tissues will cause their damage. If the iron is deposited in the liver, it will cause liver cirrhosis, and liver cirrhosis will maybe present in the form of increased liver enzymes. Again, liver cirrhosis may be transformed into hepatic carcinoma or liver cancer. Deposition of iron in the pancreas will result in the development of diabetes mellitus with different manifestations of DM like polyuria, polyphagia, and polydipsia. Iron may be or can be deposited in the joints, causing arthritis. Under the skin, it will cause bronze coloration, and in the heart, it will cause congestive heart failure. And when it affects the testicles or the pituitary, there will be erectile dysfunction with loss of libido. How can we diagnose hemochromatosis? Hemochromatosis can be diagnosed by blood tests like measuring the transferrin saturation. In such cases, the transferrin saturation becomes high, and it may be greater than 45% out of 35%. When it is higher than 45%, it may be one of the indicative for the presence of hemochromatosis. Again, ferritin will build up inside the parenchymal tissues, and it will show up high levels of ferritin in the blood. Ferritin levels greater than 300 nanogram per mil in men and 200 nanogram per mil in females may support the diagnosis of hemochromatosis. But we have to observe that ferritin to become as high as such levels, it needs time. So in early stages of hemochromatosis, ferritin levels may be normal. Again, unfortunately, ferritin levels can also be increased in many common disorders, like in cases of inflammation, not only hemochromatosis. Genetic testing is very important to reveal the presence of gene defects, as in mutation of the HFE gene, point mutation, in which cysteine is replaced by tyrosine at the position of 2A2. Other tests to diagnose iron overload, like in liver biopsy, is one of the more useful tests to determine if and how much of the liver is affected. MRI, radiological MRI methods provide useful information about the level of accumulation of iron in the liver and heart. By the end, what are the management of hemochromatosis? Hemochromatosis can be managed by a phlebotomy or removal of blood that would decrease iron in the circulation and leads to iron mobilization from the stores, and the use of iron chelation, as the use of desferal and the promising now hepcidin agonists. Hepcidin as a potential diagnostic and therapeutic tool. hepcidin may help in the differentiation between anemia of chronic disease, ACD, where there will be high hepcidin and high ferritin, from iron deficiency anemia, where there will be low hepcidin and low ferritin. Again, hepcidin measurement would help in diagnosis and monitoring of hemochromatosis, where we find low hepcidin with high transferrin saturation and high ferritin. Another use of hepcidin is it's using it as a therapeutic tool. Hepcidin or hepcidin agonists are promising tools for the treatment of hemochromatosis and other iron overloading conditions. Many hepcidin mimics the effect of hepcidin in binding with ferroportin. Many hepcidin is synthesized the first N-terminal 9 amino acids, and such 9 amino acids would mimic the effect of hepcidin in binding with ferroportin. Thank you.